What's up, ladies and gentlemen, to Open Live Q&A, week number 146. My name is Mr. McLogan, and tonight is Halloween, and it is a day later than my usual live stream, but unfortunately, I had some special events last, actually, make sure. Oh, I actually forgot to edit this on. So let me go and change this to actually published, and I'll do it again. All right, there we go. Now we are going public. Cool. All right, now it is public. So welcome, ladies and gentlemen, to week number 146. My name is Mr. McLogan, and this is Open Live Q&A with Mr. McLogan. Tonight is Halloween. I usually go live on Sunday night at 9 p.m., but last night I had to take my dog to the emergency vet. So I was unable to make it to the live stream. And so rather than kind of posting anything, I just decided to go ahead and unlist my live stream and put it from there. So I do apologize for that. For those of you that had any questions, hey 2K, and I'm not sure there's going to be probably too many people that will hop on, but hopefully, you know, some of you guys just like randomly like, oh wow, maybe I'm just getting back, getting some candy, at least in the United States. I don't know whoever else celebrates Halloween, but yeah, you know, like hopefully you get a little candy and you're like, hey, well, this I decided to go on decided to go live on YouTube because I remember last year it kind of stunk. I had to like take my kids out for Halloween, and then I got back and then I was like, oh crap, it's Sunday night. I gotta go live. But I'm kind of liking this time. I think I might move it up to 8:30 rather than the 9 o'clock time slot. That might just give me a little bit more time to, you know, I don't know, get some things through, and then also still kind of like not be so tired by the end of the night. Cause you know, 9 o'clock always worked very well when I was going back to school because, you know, I was able to do like on my routine. But yeah, I don't know. That's hopefully maybe moving up like an hour or an hour and a half or just 30 minutes might help out. So there are some questions. I'm going to go and take a look. If you guys do have any questions in the chat, feel free to add them in there. I didn't have any live topic to kind of go through on this week. I was kind of like every other week, I was trying to think of like maybe something different that I'll do. So, you know, I do have definitely a couple topics that I want to bring up, but this week was just like, hey, any other questions or anything else you guys are going on? I know some of you guys have had semester exams. If you have already taken your semester exam, let me know in the chat. If you have not taken a semester exam, let me know. I'm just kind of curious to see, you know, because now that like I'm removed from the classroom, it's kind of different to see like when students are taking tests, when students are not. And it's always kind of curious to me, like everybody's kind of schedule in that regard. So if you still have a test coming up, you know, feel free to just, you know, let me know in the chat. So get a gut. No, don't want to add one of those. All right, let's go and see what questions that I have for you guys are on. And again, if you guys have any math questions or anything else, you guys can always go ahead and submit your questions at brianmccullough.com/Q&A, or you can also go and submit them down to on my Discord. Where's my Discord? There's my Discord. You can also go ahead and join them on the Discord server at any time. It's a great resource, guys, I think, for throughout the year. But yeah, I'll try to see what kind of questions I can get through you guys from here that you guys have currently submitted. So I'll go and take a look at those. I'm currently learning the rational zero theorem. What do you think the next topic would be? Would it be complex numbers? Usually we kind of... usually we kind of, I think, cover complex numbers before the rational zero theorem. Or, yeah, usually we kind of cover them. So if you haven't covered them, maybe that might be something you're coming up next. What do you mean? Just like checking like your ability to, I'm not sure what you mean on like the numeracy tests. Like what exactly are you being tested on, like your numbers, number set? So let me know maybe a little bit more on those numeracy tests. But I think like if it's just like some basic mathematics, numeracy tests, I think those are definitely like, I think there's some foundational stuff that it should be just expected that we, you know, help students kind of get over and make sure that they can understand and do well on. So So yes, I'm assuming that's what you're talking about, but I'm not really sure. To get download videos for any awesome, and you're helping me start. Well, you're very welcome. Good job, Gabe. Awesome to you. Kudos to you. Congrats. All right, I don't want to turn that on just because I don't want to do a lot of questions tonight because it's not a regular night. Ooh, all right, increasing. Is it possible to solve a system of 3 linear equations? Yes, it is. But those questions sometimes can take, okay. Those questions sometimes can take a little bit longer, so. Oh, that's what it was. Yeah, so you got to use your calculus on that. I don't want to do the calculus right now. All right, I'll do a different one from there. Also, how are you, Mr. McLogan? Well, as well. I had a math quiz on Thursday. That's on solving quadratic equations by factoring. Okay. I'm sorry to start it right now, so I don't have to cram. Yes, that is a good idea. And yeah, just I think the main thing with like solving quadratics by factoring is practice, practice, practice. Like practice tonight, practice tomorrow, like practice a lot of quadratics. The more quadratics you can do, the more prepared you're going to be for that quiz. And wish you the absolute best of luck. All right, this was a good question. I thought this was something that is not something I get asked quite a bit, so I kind of like this one. So I'm going to go ahead and select this one if I can. So I have a good way of kind of explaining this, or at least I hope I have a good way of explaining this. Ooh, from South Africa. Awesome. Hope you're a rugby fan. Parametric equations, linear algebra. Can you please cover these? It's kind of hard to like cover a certain topic, like a broad subject, on live stream. So if you do have like a specific question, then go ahead and submit that specific question to brianmclogan.com/Q&A. And that just gives me a little bit better idea of like how to address it. I mean, as you can imagine, having an open live stream for like people from all over the world to ask questions, like, and obviously I'm only one person, like I only know so much math. I'm not a math genius. So like giving me some insight on what to teach or how to teach or what you know is very helpful. So that's why I give you guys the link to kind of post in there. Like sometimes I can ask questions inside the chat, but a lot of time it is like kind of difficult from there. I have a unit 2 test. Well, what is your test on, Brian? Like, I don't know I'm not sure what unit 2 is. That can be like on functions, like linear equations, inequalities, absolute value. Like, give me a little more information on what that's on. Hey, Araf, just submit a question. I hope it's not too late. I mean, I'll try to do my best, see what I can do. Can you recommend me a technique to use in solving a system of linear equations? I find the substitution method a bit confusing for me. Yeah, I mean, substitution and elimination are going to be your 2 techniques, but you're going to be usually using a combination of them. And hey, Carson, good to have you on. Able to cover, yeah, Carson is like, if you guys go over, and actually Carson, I haven't even chopped down, but like Carson is a amazing resource, and a really, really good math student and a really, really nice person, to answer questions and help you guys out. So if you have questions on linear algebra, I'm cover linear algebra, but through basics of it and application of the differential equations, like really, really smart dude and awesome person as well. So thank you, Carson, for hopping on. I appreciate that. You flip it across the, well, I mean, there's an easy way and a more difficult way, but yeah, you got to use kind of restrictions. But again, submit it to the link, guys. That's probably the best way to go. How do you determine the multiplicity of a 0 when you don't have an equation and just the graph? So, that's kind of interesting. Cause yeah, you could be like a multiplicity of 2 or multiplicity of 4. You might not technically know. That's interesting. Not really 100% sure. Well, all right, Brian, I mean, quadratics, I mean, I would take like a couple weeks teaching that. So I'm not sure what I can teach. I'm not sure what I can tell you in a couple minutes on helping you solve quadratics. I mean, I definitely make sure that you review the quadratic formula. Definitely make sure you review for algebra 2, make sure you review like how to graph it, in vertex form, standard form. Definitely to review factoring. Like, I mean, if you have your test, I think like tomorrow or this week, I mean, I know that's a lot. And, quadratics is tough. I mean, quadratics, it encompasses, a pretty big deal. So, don't try to do what you can, review what you can, but don't beat yourself up over all the stuff, try to do like quadratics is something that's not going to go away. So, you're going to have multiple opportunities to keep on improving upon your understanding with it. So keep on going from there. I can, but it takes a little longer. So I'm probably not going to handle it on the live stream. But if you want to submit the question, onto the live chat, I'll see what I can do. The teacher said, do you just need the least multiplicity? Teacher, okay. Well, I mean, remember, if it bounces, it's even. And if it crosses, it's odd. So that's, this can kind of be a little confusing, but I'm going to try to answer your question. Oh, I can't really answer that, can I? All right. I'll try to rate your question. Let's see if I can write it down in here. Come on. There you go. All right, I'll try to go from there. Yeah, I used to not do it for a long time as well. Like, I mean, it really kind of depends on the class and what the kind of the objective is. But yeah, for a long time, I didn't allow my students to use calculators as well. All right, let me try to get some of these questions that students pre-submitted from last week that I wasn't able to get to. Dawson, why not? I go live every Sunday night at 9 p.m. And then this week I just missed because last night I had to take my dog to the emergency vet. So I had to miss last week's live stream. Last week's last night's. Hold on. Now I'm trying to read these questions that you guys submitted. So let FX okay. I think I got this one. I don't like reading. I don't like doing questions on live, but I'll try to do my best. Well, awesome, Tulio. Happy to help you out. Do you think another manager aside from Scrum might be invented soon? Maybe. I'm not really sure. Oh, awesome, Trey. Awesome, Dawson. So happy to help you out. Lemure, you're very welcome. I don't think I said your name correctly. Hopefully, let me know. All right, I'll try to do that one. Doing tips regarding unit circles or remember trigonometric identities. That's a great question. I should probably make that's like a video question. Crap. All right, I'll try and make a video on that. Come on. Serious? There you go. All right. What other questions you guys got? Nothing coming up? All right. Again, you guys can submit your questions. If you guys do have any questions, submit them at brianmclogan.com/Q&A. And also, guys, usually I do go live at Sunday night at 9 p.m. But tonight is just a little different. You're fine. I passed pre-calc because of you. Awesome. Long-time YouTube viewer. You've all been through Algebra 1. Wow. That's kind of cool. There was actually a student that I had in my school that I taught her in freshman year all the way through junior year, but then I didn't get her for senior year. But I had her for every other math. All right. Probability, nope, sorry, don't cover that. Math is fun. Yes, it is. What's your favorite subject? Math. I would say, like, as far as math goes, I would say like graph theory I really liked. I got an A in calculus in high school, but I haven't touched math in 5 years. Do you think I should take an easier college course before jumping into calculus again? I mean, I think 5 years is not too bad. I think you probably get caught up probably faster than you think you would. I mean, again, it is kind of up to your own, like, understand like where you think you'd stand, like, or where do you think you'd be. Like, I think it'd definitely be hard to jump into the next math class, right? Like Calc 2 or something like that. But I think if you like retook calculus after 5 years, I think you'd be okay. I don't think 5 years is like, I think it'll be, you might have to do a little bit of legwork, but I think besides that, I think you'd be fine. But again, like, maybe leave that option open. If it's not something, then, don't feel bad if you have to like drop the class, and like go back to a calculus refresher. And again, like it also kind of depends on like how confident and, strong you were in math before that, right? Shane, good happy to help you out. Well, awesome, Bart. Happy to help you out. All right. Let's see. Oh my God. All right. I'm going to read your question later, but I'm not going to do it right now because I have a lot going on. Please give me one. All right. Got one. It's a big question, but I'll try to do my best. I know you had a quiz coming up, so sorry about that. I was not able to make your quiz. Somebody asked a question like, have a quiz tomorrow. I'm like, I think this is from last week. Sorry. Usually, guys, I'm pretty good. I don't mean to laugh. Usually I'm pretty good about getting the questions in. I usually started trig in chapter 4. So I usually did chapter 1, 2, 3, and 4. So I don't know how many months, but usually about 3 or 4 months before we got into trig. And again, it all depends on the teacher and all depends on the curriculum that you're following. All right. Last one. ARF, what are you sending me here? Find the coordinates of the holes. Okay, I can do that, hopefully. Well, if general chat is not the best place to send your questions. I'm not sure what your general chat is, but general chat is not the best place to send the questions. The best place to send the questions is brianmclogan.com/Q&A. I'm not even sure where your question in general chat went. I don't even see that either. Say I'm an old guy over halfway through engineering and started my math journey with you. Today is my first day of retirement from military at a ripe old age of 38. Well, that's awesome. I'm 38 as well. So congratulations. You're not that old. Well, I mean, I guess if you're old, then I'm old because we're the same age. But yeah, I turned 39 in January. So yeah, getting right up there with you. Or right up there past you. How do you find the domain and range in exponents? I mean, I think it's just helpful to know what the graph is going to look like. And then, kind of going from there. All right. I have test tomorrow on the second half of whole algebra 1 unit, and it's the last grade, so I'm so scared. And I saw one of your videos, which helped me with one of my troubles. So awesome. So happy to help you out. Shahasra? I think I said that. God, man, you guys... I hate making people's names wrong. I do apologize. But all right. So let's get into the math questions, guys. 49? I don't know. All right, let's get into the math questions and see where we're at. Because we got some decent good questions. All right. So I'll be watching the chat. There is definitely for sure, but it's going to do a little bit more higher level math, especially if you get into some calculus. We can definitely do that. All right, so let me get into what I'm trying to do. There we go. All right, so how do you factor the difference of two squares when not a square number? I love this question. So let me kind of give you an idea, right? So let's pretend I had, no, what are we doing? Let's say I had x squared minus 5. and I said, factor this down across rational numbers. Like, how can we factor this, right? Now, if this was only one number, everything would be completely different, right? If this was x squared minus 4, then I could rewrite this as an x minus 2 times an x plus 2, right? And wow, be done. Like, that's factored. Now, what's another way I could do this? Well, I could say, I could say x squared minus 4, and let's say if I set this equal to 0, then I could add a 4 to the other side and say x squared is equal to a 4, take the square root, x is equal to a plus or minus a common 2, right? Because remember, take the square root, and then you know x is equal to plus or minus 2, then you could say x is equal to 2, x is equal to negative 2, and then you could rewrite them as their factors, right? Now, once you know the zeros, you can rewrite them back in factored form. So in this case, if you don't know how to factor this out, what you could do is you could set it equal to 0 and then go and solve to find the zeros, right? So when you add a 5 to both sides, you get x squared is equal to 5. Take the square root, x is equal to a plus or minus the square root of 5. Then now, just like I did over here, right? You can say x is equal to a square root of 5, x is equal to a negative square root of 5, and then now I can write this in a factored form of x minus the square root of 5, x minus the square root of 5 times a x plus the square root of 5. Voila. All right, determine multiplicity from a graph. I'm not really sure exactly what this come from, but let me try to do my best interpretation, okay? So if I had a function, and if I said f of x is equal to a x minus 1 to the first power, okay? Well, that's going to have a multiplicity of 1, right? So x is equal to 1 with a multiplicity equal to 1. So that is going to look something like this, right? Now, what if I did f of x equals a x minus 1 squared? It's going to have a 0 of 1, but now the multiplicity is going to look like this, right? Now, what if I had a f of x is equal to a x minus 1 cubed? Now that is going to be, again, a positive 1 here, but now it's going to be the S curve. It's going to kind of like curve like that. So what I want you to understand is like the bigger and bigger numbers I get, right? So let me do like some big different numbers here, because I don't need to make like more graphs. If I did like f of x is equal to a x minus 1 to the 4th power, it's basically the same multiplicity, right? It's going to touch it. It's just going to get wider, right? And the same thing over here. If I said like f of x equals a x minus 1 to the, let's say to the 5th power, it has the same properties. It just gets wider and wider. So it's kind of hard like for me to say like, oh, this is like x to the 5th or x to the 7th. Like I'm not really sure what the multiplicity would be, right? Because here the multiplicity is 4. Multiplicity is 5, right? Whereas here you could say multiplicity is 3 or the multiplicity is 2. Like it's kind of all varying in that regard. But yeah, hopefully kind of idea like the larger that number, like the wider and more stretch it's going to get. All right, and this one says let f of x represent a function with the domain x is less than or equal to 7. So let f of x represent a function with a domain of x, which is less than or equal to 7. So domain is x, which is less than or equal to 7, and a range. Okay, so here's the domain. So the range is going to be x is going to be a range. It's going to be x is less than or equal to 2. X is going to be less than or equal to 2. Okay, so it's not going to be a range with the x. It's going to be with a y. Y is going to be less than or equal to 2. So if you're going to look at this something like, you know, you don't really need to look at like what a graph is, but you can make a graph if you want to, right? X has to be less than or equal to 7. So 1, 2, 3, 4, 5, 6, 7. And y has to be less than or equal to 2. So 1, 2. Okay, so it's going to be less than 2 and less than or equal to 7. So let's just kind of do something like that, right? I don't really know what the graph looks like. Now, the important thing that I want you guys to understand is when you're dealing with the inverse, that's going to be reflected about the y equals x line. Okay, so this graph is going to be reflected about this line. What's also important about reflecting about the y equals x line is the domain and range get swapped. So now my domain is going to be, if you were to reflect this, okay, about this line, then this graph is going to be, we're flipped over from there. This graph now, and I'm not really sure exactly the case, but you could say the y is going to less than or equal to a 7, and my range is going to be x is going to be less than or equal to a 2. So what's going to happen is on this graph is we flip it over, which is not really correct, like how it's shown, or it doesn't really look good in this case, but it'd be 1, 2, come on, 1, 2, 3, 4, 5, 6, 7, and then over 2, and it would look like this from on there. So you can see how it's not really great and perfect in that regard, but you can see exactly kind of how that's, how it's kind of being reflected about that line. And the main thing though, is that the domain and range are being swapped, okay? So you can see how those things are being swapped from that regard. Oh, okay. Thanks, Carson. Hello, do you have any tips regarding unit circles and remembering trigonometric identities? Yeah, I do a little bit. I mean, I think if you're trying to remember the unit circle, I mean, you could do like the 5, fingertip or whatever, but I think the main thing, like every student needs to understand, right? Here's your unit circle. You got to know the first quadrant, okay? And remember this first quadrant, right? You're going to have these 5 major important points, okay? So this point is 1, 0. This point is 0, 1. Okay. Now from here, basically what you're simply going to be doing is you're drawing these little dashes here. Okay. And what you're going to do is square root of 3, square root of 2, square root of 1, and then square root of 3, square root of 2, square root of 1. Okay. And then everything is going to be divided by 2. So it's square root of 3 to square root of 2, square root of 1. And the cool thing is what happens here is this is your coordinate point over here. This ends up being just a 1/2, right? Square root of 1 is just 1. So now what you're going to have is square root of 3 over 2, 1/2. 1/2 comes square root of 3. And then these angles, I'm just going to use radians here. That's going to be pi over 6. This is going to be a pi over 3. That's kind of hard right in the small. This is pi over 4. And this is going to be pi halves. Okay. So you have to know that first. You have to know that first quadrant. Now, the other thing, as far as remembering the trigonometric identities, kind of goes along like that same idea, right? So if you think about like on the unit circle, here is your little coordinate point, right? Now remember, this is your x, this is your y, that's your x, and that's your y, right? Now, if we were going to say like, if this is 1, right, because that's the unit circle is 1, you could say that the sine, and here's theta, sine of theta is equal to x, right? And I'm sorry, not x, it's equal to y. And cosine of theta is equal to x. So therefore, if this is equal to cosine of theta, and this is equal to sine of theta, right? They're equal to each other. Well, guess what? You can now kind of write the Pythagorean theorem, and you can now say that cosine squared plus of theta plus sine of theta is equal to 1. And that is now going to be your trigonometric identity. So I always kind of think about that Pythagorean theorem in that case. And then the easiest way to convert from one trigonometric identity to the others is just to divide everything by sine or divide everything by cosine, and you'll be able to go ahead and get the other identities. All right. Now let's go and do some rational functions. So here I have y equals x divided by x minus 2. So in this case, what I do is I would factor on my denominator x minus 1 times an x plus 1. Okay. Now nothing is removable. Okay. So removal will be because divided in the numerator and the denominator. That's not happening. But I do have 2 vertical asymptotes, right? So I can set my denominators equal to 1. Or I'm sorry, set my denominators equal to 0, and I'll get x is equal to 1 and x is equal to a negative 1. So let's go ahead and write a asymptote here. And then let's do an asymptote right here. Okay. All right. So we got these 2 asymptotes. Their horizontal asymptote is when the degree is larger in the denominator than the degree in the numerator. Then we have y is equal to 1 is my horizontal asymptote. Okay, so that is my horizontal asymptote. The domain looks like everything's going to be continuous, right? Except for these 2 vertical asymptotes. So my domain is going to be from -infinity to -1, union -1 to 1, union 1 to infinity, right? Because there's no reason for me to see a discontinuity except for my vertical asymptotes. As far as the range goes, same kind of idea. However, I'm not sure if my function is defined at this asymptote or not. So I'm going to need to kind of verify. I'm going to need to like check to see what this is going to look like. So before I do that, I'll finish this out. And then let's go and see the x-intercept. So the x-intercept is when y is equal to 0. So let's go and plug 0 in for y. So 0 is equal to x over x squared minus 1. Set the numerator equal to 0, so x is equal to a 0. All right, and the y-intercept is when x equals 0. So if you put x equal to 0, that's going to be 0, 1, so that's going to be 1. So I'm thinking I'm going to have like a little S-curve or maybe an upside-down parabola. Let's go ahead and let's go and plot some points. So a lot of times when you're graphing this, you want to see like, what are some coordinate points they can plug in? Let's go and plug in, I don't know. Crap, this thinks this is between 1/2. So let's go and pick 1/2. And then let's do -1/2. Actually, is this an even function? It's not an even function, so there's no symmetry. Okay, so that's important. So since it's not an even function, I know that's not going to be symmetrical. So therefore, I am going to want to choose -1/2 and 1/2. So remember, you can always plug in like y sub -x, right? And if you get back the original function, it is odd. I'm sorry, it's even. If you get back the opposite of the function, then it is odd. And what's going to happen here is, no, we're not going to get the opposite of the function. Okay. I wonder what this graph is going to look like. So let's plug in 1/2. That's going to be a -1/2. That is going to be a 3/2. So let's see. I'll have a x over -1/2. X plus 1/2 is going to be a 3/2. So, and that's a 1/2. So if I did y sub 1/2, therefore that's a -3/4. And then multiply by reciprocal, 4 over -3, 4 over -3. That's going to be a -2/3. Oh. So that's going to be -2/3 and -1/2. Okay. And then let's try a y sub -1/2. So if I did that, that'd be a -1/2. And then this would be a -3/2 times a 1/2. And that's going to be positive. Okay, but yeah, it's not going to be, it's not going to, okay. So I'm thinking this is going to be like an S-curve here. I'm actually just going to cheat. I'm going to go to Desmos because I don't have time for this. But I believe, let me actually go and check. I believe this is going to be an S-curve, right? Okay, and then let me go and check at -2. So at -2, I'd have a -2, -3. So it'd be -3 times a -1. That'd be +3. So it'd be a, let's do not -3. Let's do a negative. So if I did a -3, let's do -3. Oh, let's do -4. Okay, so -4 over -5 times a -3. Okay, so that'd be a -4/15. Okay, so that's probably going to look something like this. And then let's do a +4. So if I did a +4, it'd be 4 minus 1 would be 3 times 5. That'd be +4/15. +4/15. I'm not sure. You'd want to do like a couple more tables in here, but it's late. So I'm going to go ahead and check see what my graph is going to be like in this. That's a great one. I love it. And you know, I mean, don't don't sweat it. I mean, it's your first observation. There's a lot of times I had maybe 3 or 4 principals. I mean, do your best, but I've had, your class, I would always, the only advice I can give you is just like try to talk to your kids and try to be like as real to them as possible. Like, hey guys, here's my first observation. If you guys can be like really, really on good behavior, I would greatly appreciate it. And I was right. Okay. So that is going to go like from there. So my intuition was correct. Cool. But actually I had that wrong. My S curve was actually the other way wrong. So my S curve actually looks like this. I should have checked more of those answers. So maybe that was a positive then. No, it was a negative. Oh, -1/2. Oh, that was a positive 1/2. Oops, I'm an idiot. Okay, yeah, that was right. But yeah, I'd maybe talk to your students, if you can, ahead of time. All right, but yeah, that's what that graph roughly looks like. And then this one was find the discontinuities or find the holes. So when you're trying to find the holes, what you're looking for is terms that are going to divide in the numerator as well as in the denominator. So the main thing you want to do is factor, factor, factor. So in this problem, I can factor out a 5x. And that's going to leave you with an x minus a 5. Over here, I can factor out a x as well. And that's going to leave me with a x minus a 5. Okay, so here you can see the x's divide out and the x minus 5's divide out, leaving me with just a 5. Okay, however, there are a couple terms though that still make my denominator equal to 0. X equals 0 and x minus 5 is equal to 0. Or actually, let's set the denominator equal to 0. Okay, so we can say x times a x minus 5 is equal to a 0, right? So we have 2 cases where my denominator is equal to 0, when x equals 0 and when x minus 5 is equal to 0. Then you can add a 5 to both sides, x equal to a 5, and these are going to be your 2 cases, right? However, they both got divided out, so these are both going to be your holes, or what we call our removable discontinuities. So there you go, ladies and gentlemen. I apologize for missing last week with all of you, but hopefully you guys had a great Halloween. For those of you that went out and got some candy, you guys had some amazing candy, and I look forward to seeing you guys and answering your questions next week. Thanks so much. Cheers.